We're on the topic of finding derivatives using the power rule of the derivative. Now, I hope you guys had time to do this one. Remember, our form is we want something written in the form ax to the power n, in that form. Whether this is a f of x or a d dx, the notation for all of those we said was the same. It's not in that form. Now, folks, if we look at it, we see there's an x on the left, there's an x on the right. There's two y's on the left, and the y is usually represented by an f of x. Okay, but in this case it's not. So pay attention to what I'm going to do in the notation I'm going to use. We're going to take the y out here. We do not want it spread all over. If we remove it as a common factor, we have x minus 1. On the other side, we've got 2x squared minus 2x waiting in the wings for us. So if I now get y by itself, I can see I'm going to form a denominator of x minus 1. Now, problematic. It's not in that form. That's the first problem. The second problem is it's not just an x that's in the denominator. It is an x minus 1. It's a binomial. So we cannot just cancel and do what we want to that x. The x minus 1 as a whole must be doctored. Okay, so let's see how we do that. If we look closer at the top, there's a common factor of 2x. If I remove it, I have x minus 1. And there again, the devil is in the detail. Those two things are now gone. They've removed from the derivative. Why did I know I had to do that? Folks, it's a binomial in the denominator. If it was like this, look at this. If I said this was 2x squared minus 2x divided by 3x, then I can rewrite this as 2x squared over 3x minus 2x over 3x, because that's in fact what happened there. I can cancel the x and the 2 leaves a 1. The x's go, and finally I'm going to differentiate that thing. But that was one term in the denominator. We stuck with two of them, and we saw that if we factorize the top, just like with the limit, we factorize both of them, we can remove the problem. Now pay attention to the notation. The notation, just a reminder, this is Jessica's question. Jessica, I am now going to take the derivative. So I'm going to say the derivative of y with respect to x, dy dx, means the same thing. Okay? I'm going to differentiate 2x. And remember what we said, if there's something times x, the x just disappears. Why? Because it becomes x to the 1 minus 1, which is 0. Okay, so in this case, we've got 2x that we're differentiating, so the 2 remains. So dy dx is indeed 2. Jessica, I hope that that helped you. What's nice about this question was the way in which it was given.